Okay, greetings everyone, and welcome into my channel. I am Professor L, and this is a live stream for Math Help. Happy Friday. I hope everybody's doing well. So trying to, moving forward, trying to learn from my mistakes and see how we're doing. Okay. So today I am going to be continuing working with this Quartic function. Remember, it's a fourth degree polynomial. And I am going to continue sketching the graph. And so I have a pretty rough sketch here. And I'm going to use the first and second derivatives to find some critical values in the graph and see if I can't sketch a more accurate graph. So I noticed the graph here that this might be a maximum value. I'm not quite sure, but it looks like it might be. And then I'm also noticing here and here that it's probably a symmetrical graph about these 2 points, but I'm just not sure how far they go down. So I want to find those minimum values here so that I can sketch a real good, better, I would say, better sketch. So what we did was we used the rational roots theorem, and we split this polynomial up into its prime factors. And then we used these factors to find the zeros of the polynomial. And what I mean by zero is specifically the values where it's crossing the x-axis here on the Cartesian coordinate system. And when we're talking about finding critical values of the graph, specifically what I'm referring to is values, maximum, minimums, intersections of the origin. So specifically where it's crossing the y and x-axis would be critical values of the graph. And then there's these things called inflection points. An inflection point is just where it's changing from an increasing to decreasing, or if it's vice versa, if it's changing from a decreasing to increasing. So, at points there will be inflection. And really, I can go ahead and get into it by first using the power rule to calculate the first and second derivatives of this function. And what basically one of the applications for derivatives, and let me back up and remind what a derivative is it's a function derived from another function using a general rule. So that's essentially what it is. It's a new function derived from an original function. So like in this case, which I don't want to erase these because I don't want to have to, I probably need both these forms. So just in case, I want to star them and keep them. But what we're going to do is we're going to first calculate f prime of our original